Good day, my name is Martin Becher and today we will talk about Introduction to Climate Change. And for this, we will first talk briefly about Glossary, different terminology issues, then about the greenhouse effect, what emission and emission scenarios are, what about certainty when we talk about climate change, and finally, about impacts of climate change. Let's start with the glossary. Make a break in your video and try to define in your own words what weather is. So weather is quite easy to define. In fact, weather is what we see outside. So I could say in a specific place, for instance here, the weather is fine, it's sunny and we have roughly 20 degrees. And how would you define climate? So climate, in fact, is the mean weather over a longer period of time, usually 3 decades to centuries. So I could say the climate in the place I am right now is hotter in summer, rainy from December till March. That's my climate here. And how would you define climate variability? So climate variability are variations of our regular climate that are normal. So sometimes we have years when it's a little bit hotter, others where it's cooler. Some years are wetter and others drier. And that's all okay. And it's just natural variability around the term climate in our place we are. And what is climate change? So that's a little bit trickier. Climate change is defined by the IPCC, Intergovernmental Panel of Climate Change, as a change in the state of the climate that can be identified by changes in the mean and or the variability of its properties and that persists for an extended period, typically decades or longer. Meaning that the climate that used to be the normal climate in my place, in my region, shifts for good. So for instance, mean temperatures in summer are no longer 30 degrees, but maybe 33 as the new normal. And the rainy season isn't anymore from December till March, but maybe from January till April. Let's talk about the greenhouse effect. The greenhouse effect is in fact something quite nice because it is an effect that helps to heat up our planet Earth. Without the greenhouse effect, our planet would be much cooler. So from this point, it's something positive. The greenhouse effect happens when solar radiation that powers the climate system hits our planet. Some part of the radiation is directly reflected back to the atmosphere, but roughly 50% of the solar radiation is absorbed by the surface. It's warmed up and then it's expelled again as infrared radiation. So part of this infrared radiation is emitted and goes directly back to outer space, and part of it is reflected by so-called greenhouse gases like methane or carbon dioxide. And if this effect happens several times, the reflection in a zigzag, we kind of recycle the heat, and this heats up our atmosphere. And as you see, carbon dioxide not always has been the same concentration over time in our planet's history. As you can see, the concentration varied between 180 parts per million and maybe 300 parts per million over the last 800,000 years. And that's a normal variation. But in the last decades, this concentration has dramatically increased to 480 parts per million in March 2021. And if we look into the future and we continue emitting like it is, it might even raise to more than 800 parts per million by the end of the century. And the effects can already be perceived today. When we compare temperatures from 100 years ago and right now, you can see that certain parts have really strongly increased temperatures. And parts of Africa of the Nile Basin Initiative area are actually heating up a lot. How will the future look like? For this, scientists from the IPCC have developed so-called representative concentration pathways. These are scenarios that are labeled after a possible range of radiative force values in the year 2100, and that more or less tell a story how our future could look like. So if we, for instance, decide as humanity to more or less instantly stop emitting greenhouse gases, the temperature will more or less stop increasing in a couple of decades and start to drop. But if we continue emitting like it is right now, we will continue to experience more and more greenhouse gas concentrations in the atmosphere with consequences for all of us. And it makes a lot of sense to look, when we look into the future, to see about which climate scenario we are actually talking about. Here you see two scenarios, the RCP 2.6, which we can call low emission scenario, and RCP 8.5 as high emission scenario. And for the year 2100, differences in temperature are dramatically different for both scenarios. And also the same for projected precipitation change. On the left-hand side, for RCP 2.6, there will be changes of precipitation, but they are by far not as extreme as for RCP 8.5, where many areas will experience dramatic decrease in precipitation and others quite a strong increase. So it is quite important to communicate well about climate change, and one of the issues to communicate about is about the degree of certainty. For certain issues regarding climate change, climate impacts, there is quite a high degree of certainty, which IPCC calls virtually certain, meaning 99 to 100% probability, and others are exceptional unlikely. And for others, it's about as likely as not, so big degree of uncertainty. And in order to be able to communicate about certainty, the IPCC has developed this simple framework over here, where they ask scientists or communicators to, on the one hand, analyze the agreement. So if I have a set of information, do all these data sets show, for instance, that temperatures are rising or dropping? So if all show the same, then it's high agreement, and if it's more or less leaks, then it's low agreement. And also to have a look at the evidence, meaning the type, amount, quality, and consistency of the data sets I currently have available. And once you cross this, you come to a confidence scale of rather high or rather low. Let's talk about impacts of climate change. So far we mainly have talked about so-called climate change signals. So changes in temperature patterns and precipitation patterns, maybe also sea level rise, which are the primary signals that something is changing in our climate. Out of these climate signals, We can also take as a consequence climate change effects. So out of precipitation patterns, for instance, longer droughts, or increase in extreme meteorological events, storms, heat waves, extreme precipitation, or extreme heat, or also, for instance, melting of ice shelves, glaciers, and permafrost. Out of these climate change effects, which are also called hazards together with climate change signals, we can derive biophysical impacts. That are impacts of those hazards on the biophysical parts of our planet, like loss of land, exception of floods, bushfires, etc. And when these biophysical impacts hit our societies, we have so-called socioeconomic impacts, which could be loss of income, loss of infrastructure, and that, on the other hand, could derive on economic loss and put our livelihoods under risk. That's it from my side until now. Thank you very much for your attention and looking forward to our next session. Goodbye.